Welcome to the lectures about experimental designs. We've talked about descriptive statistics, we've talked about descriptive designs and non-experimental designs, and now in this group of 3 lectures I'm going to talk to you about experimental designs. The learning objectives, or what I want you to take away from this, is I want you to be able to explain the purpose of experimental research and how it's different from the non-experimental types. You need to be able to pull up the characteristics of experimental research. In other words, what makes it experimental research? And then there are 4 designs that we're going to talk about: pre-experimental, quasi-experimental, and experimental. And then the 4th one is single subject. I'm just going to talk briefly about that because it's very seldom used. Why is experimental research so important? It's actually becoming more and more important. The federal government especially has been putting a lot of pressure on educational researchers and publishers and grant-funded programs to show that to do true experimental research, and it's very difficult to do in an educational setting. But the important piece of experimental research is that it's the way you can design a research study so that you can confidently say that there's a causal inference. You can make a causal inference about the relationship between the IV and the dependent variable. In other words, with experimental research, we're trying to say that this independent variable, an intervention, a schedule, a teaching approach, a learning strategy, whatever it is, causes a particular outcome or dependent variable. And experimental research is the only way that we can really confidently say that. So then, when you're looking at experimental research, what makes it experimental research? There are 2 things. First of all, you must manipulate at least one independent variable. Now, I talked in non-experimental research about how the independent variable can change, but it doesn't change, or it's not different between the groups because we change it and we control for that. The other important characteristic of experimental research is that we control for all the extraneous variables. We try to hone in on the independent variables that really truly make a difference. So let me talk a minute about causal inferences. This means that we're taking a set of data from a research design and we're saying this independent variable, what we did, what we manipulated, actually changed the outcome or the dependent variable. So there's 4 pieces that need to be there if you're going to actually make a cause and effect kind of inference. First of all, there has to be causal relativity. In other words, you have to have 2 things. You have to have an independent variable that causes a dependent variable. So you've got to have X and say that it causes Y. So you've got to have these 2 things that go together somehow. That's the relativity part of it. Then you have to have causal manipulation. In other words, the researcher changes the independent variable or the level of the independent variable. In medical studies, often the researcher changes the amount of a medicine, or gives some people a placebo and some the true medicine. And all of those are ways that we manipulate the independent variable. In educational research, we could change the independent variable by introducing an intervention that some of the children get. We could introduce a professional development program that teachers go through. We could purchase a curriculum and compare it to another way of teaching. All kinds of things. Third, there has to be a temporal order. In other words, the cause has to sensibly go before the effect. So if you're going to say that this intervention, this one's so obvious, it's almost silly to talk about it. But if you're going to say the intervention has an outcome, you have to give the intervention before the outcome can be measured. So that's what we mean by temporal order. And sometimes there's a natural order to this. And then the fourth piece that's really important if you're going to make a causal inference is that you have to eliminate all the alternative explanations that you can possibly think of. And this is where we get to internal validity. We eliminate all the others, and then we can say that internally what we did is what caused the effect, and we can feel really confident in doing that. So now there's some other characteristics that are really important with experimental research. First of all, with experimental research, there should be a true hypothesis. And we'll get into that when we talk more about inferential statistics. But in true experimental research, there are theories and there's previous research and a basis for thinking that something will happen. We don't just say, I'm going to purchase this curriculum and it's going to be the best thing ever. You have to do the research first and have a theory behind it and a reason. We call it a theory because it tries to explain why it happened when you get into theory-driven hypotheses. You have to start out with statistical equivalence among the groups. In other words, if I take 3 groups of children and they are very different in age, or they are very different in their reading ability, or they are very different in an aspect of their health, the groups aren't equivalent. So we usually use random selection in experimental research, and I'll talk about that in a minute. But in experimental research, you have to look at the groups and make sure that they are roughly equivalent before you start anything. I've already talked about the researcher manipulating the independent variable, but you'll hear me say it over and over and over again because that's how you distinguish experimental research. When you measure the dependent variable or the outcome, that can take a lot of different forms. It could be test scores. It could be an attitude scale. It could be some kind of mastery that the kids have to produce, or a portfolio, or if it's say it's a professional development program for teachers, one of the outcomes you would expect would be particular behaviors happening in the classroom, or lesson planning, or something like that. Experimental research is where we actually get in and use true inferential statistics, not just describing what is, but doing an analysis to be able to say how much confidence we have in saying that the intervention affected the outcome. And then there's the control of different conditions and external variables. And all of those are characteristics of experimental research. Experimental research in the educational setting is very, very difficult. And I've talked about this before. Remember a slide from a previous lecture where I described why we don't very often do experimental research. Sometimes we cannot, sometimes we should not, and sometimes we will not. And you can go back to your notes and remember the discussion about those. And sometimes in experimental research, one of the problems you run into is almost counterintuitive. If you're doing a true experiment and you control for every factor you can possibly think of that might influence the outcome, and you actually have an outcome or you get your findings, well, will those be real in the real world where all of those other variables aren't controlled for? You can control an experiment so tightly that it loses its ecological validity. In other words, you're not likely to have the same results in real life because you've controlled for so many things. And so that's always a fine line to walk. How much do you control for, and how much do you let go so that it's more like a real classroom or a real situation that you want to do. It's really important as consumers of research that you can understand the limitations of any study when you're judging its usefulness. So you've got to understand these terms and come to grips with what the researcher was doing so that you can make really good ideas or judgments about how you're going to use it. Now, as I talk about experimental research, there are a couple of terms that are really, really important. First of all is random selection. Go back to your text and look for this one if it confuses you or you're not quite clear what it is, because it is so absolutely central to experimental designs. Random selection means that you take your population and you randomly pull out subjects or groups from that population. Totally random. You just run a computer program and it tells you which subjects to pull out. And that's your random selection of subjects or groups. And what that does, you'll remember from a previous lecture, that allows you to generalize your findings back to that population. Random selection means that your groups that you these people you randomly select should, statistically, they're going to have the range of the whole population if you've got a large enough sample, and you can recall lectures about that. Now, once you've got this random selection of participants or groups, let's talk about participants, then you have another layer of it, and you randomly assign those people into different groups or conditions. So if you're going to have a group A that's getting an intervention twice a week and a group B that's getting the intervention 4 times a week, and you're going to have a group C that's your control group and they get no intervention, well then you're going to randomly take your randomly selected kiddos and you're going to plug them into those 3 different groups. And this is critically important because it means that through random assignment, your groups are going to end up being roughly equivalent. Not perfectly or exactly the same, but really close to equivalent groups. You should have the range all the way across in every one of those groups. Now, it's truly random. That means that if I randomly assign those kiddos in my sample that I've randomly selected to 3 different groups, and then I turn around and throw that out and I randomly assign them to 3 different groups, it's not going to be exactly the same. It is truly random, and that's very important. Another term that you will see a lot in experimental research is fidelity, or program fidelity, or intervention fidelity. And what that is talking about is what is happening in that intervention really truly the condition that the researcher planned. In other words, if I have an intervention, I'm going to have the teachers gather children in and they're going to use manipulatives 3 times a week for 45 minutes each time, and in teacher-led activities. That's my intervention. Well then, if the teacher doesn't follow those instructions exactly, then it's introducing another variable or another factor, and it's changing the data that I'm going to get. So there's 5 things that you look at when you judge the fidelity. Was there adherence to the intervention? Did the people involved really do what you wanted them to do in that intervention? Did they really get the sleep that you wanted them to, or whatever the intervention is, the exercise, the reading minutes? Was the intervention long enough and frequent enough? So if you've asked teachers to do this intervention 3 times a week, did they truly do it 3 times a week? And was it long enough? Maybe 1 week wouldn't be enough to find an effect. So how long do you need to continue this? so that you've got fidelity to the actual intervention. The researcher should describe to you the quality of the fidelity of the interventions. So if I'm going to, and this goes back a little bit to adherence, but you want the quality to be there and stay true to the intervention. Another factor that's hard to judge is the participant responsiveness. I could do that intervention with the manipulatives 3 times a week, but if the kids are just sitting there bored out of their minds or refusing to participate or can't engage for some reason, maybe there are language barriers, anything at all like that, then I'm not going to have fidelity to my intervention. And then there's another piece where you have to ensure that the conditions are actually different. If I'm going to say that this teacher is going to do the intervention for 42 minutes a day and this one's going to do it for 45 minutes a day with 3rd graders, that's not probably going to give me enough difference between the conditions to really truly find an effect. So the researcher should help you make a judgment about these 5 things as to whether you can look at it and see if there really truly was fidelity in the research design to the intervention. Now, I've talked about internal validity before. Internal validity means, remember, that you're really confident that the independent variable, what you manipulated, led to the outcomes, to the dependent variable that you're measuring. And you've minimized the influence of other variables. Now, the opposite of that, or what goes along with that, is external validity, where you can take what you find and you can generalize it out to the population. The problem you have is that these two kind of get in conflict with each other. So if you increase your internal validity, you minimize, you control for all the other variables so that it's just the independent variable and you're really, really certain that led to the outcome, you're not going to have as much external validity where you can generalize it out to the population, because out in the population, all those other factors are going to come into play. And this is where you get the ecological validity, when you're looking at the external validity. So the researcher has to make a judgment and should justify how much control they had or did and how much they let other factors influence so that it can be generalized out. And that's, as I say, that's a very difficult thing to manage to do.